My name is Yash Sharma. Welcome to Machine Learning in the Sciences, the podcast where we explore the intersection of cutting-edge, data-driven technologies and scientific research. In each episode, we'll delve into how data-driven technologies are being utilized in the real world. From biology to computer science, chemistry to ecology, we'll bring you insights from leading experts in the field and examine the potential impact of these exciting advancements. Stay tuned for some amazing conversations. Hello, everyone. Welcome to the Machine Learning in the Sciences podcast. Today, I have Eric Siegel with me on Zoom. So I noticed that, your introductions are really, really long. I was listening to a couple of your previous podcasts that I think just recently came out. So instead of kind of starting out in a normal way where, someone lists like all that you've done, and you've done a lot, starting from teaching at Columbia to predictive analytics world, but what I really want to focus on is how you're like Dr. Data. So there's a picture of you with a giraffe in, I think, South Africa. So how did that come to happen?
So Yash, first I just want to say thank you so much for having me on the show. And I really appreciate you starting off with Dr. Data, which is my preferred handle. Unfortunately, nobody calls me that. I've been trying to beg everybody, my friends, to call me that, my colleagues. But I my Instagram account, which doesn't have very many pictures, does have a picture from South Africa in 2015 or something. I actually gave a keynote at a conference in Cape Town. And when I was also visiting Johannesburg while I was there, I made a nice tourist trip out of it. I went out of Johannesburg with a new friend. We went to some kind of it wasn't a safari, but it seemed like it was more than a zoo. I can't remember the word for it, but you could get up on this platform. So when the giraffe came by, I got the selfie with the giraffe.
Yeah. And so that was you were just in South Africa for business, right? And you wanted to film shots for your music video?
I was traveling a lot that year leading up to when we shot the music video in LA. I was living in LA at the time. Now I'm in the SF Bay Area. And the music video of which you speak is Predict This, and it's just 3.5 minutes long. You can check it out at predictthis.org. We'll get you to the right webpage. Very educational. Predictive analytics is basically a synonym for machine learning, at least for a broad class of business applications thereof. So while I was doing the traveling, which was mostly for work, but it brought me some pretty good locations, and I would sort of bring my nerd costume with me everywhere I went, put it on, embarrass myself in public, and get some shots in front of the Parthenon and all different locations around the world. So there's a portion in the middle of the video where you very quickly see me a whole bunch of different places globally, even including Antarctica, and it's all real.
Yeah, no, I saw the one at Sri Lanka. You're just walking into the club, and it looked.
But is that the outtake?
Yeah, that was
my YouTube channel.
Yeah, I was just looking at it, and it just seemed so so awkward almost. But yeah,
well, that's just my ulterior identity, Dr. Data.
Yeah.
In real life, I'm not actually a nerd at all.
Yeah.
Right?
Yeah. No, of course. So I guess let's start off by kind of going into like this data, right? What is the idea behind predictive analytics?
So predictive analytics is basically a synonym for machine learning. It's where you're learning from data to predict. You generate a model over previous examples, the way things have turned out in the past, which individual has. The title of my book is Predictive Analytics: The Power to Predict Who Will Click, Buy, Lie, or Die. So those are just 4 rhyming verbs of all the different kinds of outcomes and behavior you might want to predict to drive all kinds of organizational decisions to better target marketing, fraud detection, credit scoring, insurance selection, ad targeting. All these things are best targeted by way of prediction. And ultimately, that's what machine learning does. It learns from data, from known cases where you usually found out from history who bought, buy, lied, or died, who turned out to be a bad credit risk, who defaulted on their loan, et cetera, any outcome and behavior. Or if you're trying to label images, you need to actually have manual labeling. But one way or another, you've got a bunch of cases that you're learning from in order to make these predictions. And ultimately, that is the mechanism that machine learning delivers. It outputs a model that looks at the particulars about a particular case, such as a customer who might cancel, or every pixel of a photograph that may or may not include a cat or a traffic light, and then outputs a probability, a prediction of what are the chances that the model would calculate that the case is positive or negative in the simplest types of applications. And that applies even in the most popular new rendition of machine learning, which is generative AI, where it's predicting what should the next word be. It's a little bit more complicated than that. It's a token, but it's basically on that level of detail of, I've written these 300 words. What should the next word be? Okay, now I've written these 301 words. What should the next word be? So it's using the same core technology, that ability to learn from examples. And in the case of predicting what the next word is, there's plenty of examples. You just take, the trillions of words we have across the internet and books and everything, and then you divide it into learning cases. You withhold the last word or the next word, and you say, can the model predict what this next word would be? And by tuning over that much data and using the most advanced forms of machine learning. But broadly speaking, it's still the same conceptual thing, even when you're just taking a few dozen elements about an individual customer, predicting whether they'll click, buy, lie, or die, or cancel, or commit fraud. It's the same basic idea. In the case of generative AI that's doing image classification, they did a little clever twist, but basically you're starting with a random image and you're trying to tweak each pixel of the image iteratively as it starts to come into focus into whatever it is it's trying to draw. So it's literally predicting for each pixel, which direction should I bring? Should I make it lighter or darker, given where it is now, what its immediate environment is? And then it's applying the model iteratively for each pixel. So in that way, it's a little more convoluted than what you're doing with generating text, where it's just predicting the next word. But either way, you're using a model to predict. And so there's this commonality and between those different ways of using machine learning, but of course, they're really quite different. When you're applying it for the traditional kind of predictive analytics, what is the outcome? It often comes down to human behavior, which is in a sense unpredictable, in the sense that you can't predict with high confidence. You can't say, I know that this customer is definitely going to buy an ice cream cone next Tuesday. But you can put odds on it. You can predict a lot better than guessing, and that turns out to be really, really valuable. And that is a big difference between the way people conceive of predictive analytics, kind of business applications of machine learning, and today's excitement about generative AI. Generative AI, everyone wants to sort of attribute some type of quote unquote intelligence to the system, which may or may not be true. It's a very subjective word. Depends on how you define it, which most people don't.
I mean,
even try to do. Versus a very practical thing where it's just, hey, this thing can learn from examples to predict better than guessing consistently. That's really valuable for targeting, marketing, and all these other kinds of large-scale business operations. And that's where most of my career has focused. That's the focus of both my first and second book. My second book's coming out in February. It's called The AI Playbook. So the terminology is kind of a problem, right? People don't really know what they're talking about when they just say AI, or what someone else might be talking about when they say, when you hear the word AI. But one way to distinguish is generative AI versus predictive AI. And if people are calling it that, which is sort of a new term that might help distinguish it from generative AI, although it hasn't really fully caught on yet, that's the same thing as predictive analytics. And either way, you're using machine learning to predict, to improve business operations.
Yeah. So that's the idea is essentially that we're trying to predict the next step that somebody's going to take in the real world, essentially, right? And so from a business perspective, let's say that I'm like an ice cream shop. how exactly would I go about, using predictive analytics in my operations? What type of data would I, end up collecting? How exactly would I process this data, and how would I ensure that my ML model actually gets, implemented into the real world?
Right. Well, that last one ends up being a bigger clincher than most expect. But so first of all, an ice cream shop, if it's in isolation, typically wouldn't have enough data and wouldn't have large enough operations to make the numbers games that you can play with predictive analytics, with these types of use cases of machine learning take effect. But if you had, 100 ice cream shops across the US or 1,000, then you're starting to get at scale where it matters. And it's large organizations, or at least organizations that have lots of operations. So it can be a small or medium operation if the data is big enough. So if there's some specialty catalog that sells candy, and they're going to send one direct mailing a year around the holidays, they might have 100,000 candidates on their postal email list, or rather, sorry, postal mail list, and they want to whittle that down and focus by predicting who's going to buy. That could be a pretty small company, but they've got a large enough data, a large enough number of decisions. You basically, for targeting marketing, and if they have 100,000 prospects, they want to make 100,000 yes/no decisions about who to target with the next mailing, with the next marketing campaign. So in general, ice cream, any kind of food vendor, right? There's marketing, there's product recommendations. Which toppings do you think this customer might want with it? And there's supply chain issues. Which ice cream flavor are we going to run out of? We don't want to stock there's a cost to stocking too much. There's a cost to stocking too little. And that comes down to prediction just as well. So one way to think of it is basically any large scale operation. And again, if it's an ice cream shop, there better be a number of ice cream shops so that in aggregate, it's a large scale operation. But for any kind of organization, business or government or nonprofit, where there's a large number of decisions, where it's a large scale operation in that respect, it's prediction that's the holy grail to improving those decisions, right? What should I screen for fraud? Well, what's most likely to be predicted as most likely to be fraud? Which healthcare patient should I administer a certain test to? Well, it's the one that's most likely to have this diagnosis, or the one that's most likely to develop a certain problematic health outcome. So you can also think of it as a way that you're always applying the healthcare concept of triage across any kind of organization, including business. You're triaging, you're prioritizing. If you're a salesperson, you've got too many leads. You can't spend time with all of them. You need to order them. Search engine results are the same thing. There's way too many results, and the whole purpose of the search engine is to put them in an order. And indeed, Google, from the get-go, uses a predictive model, the output of machine learning, to order your search results. So does Airbnb orders your personalized search results for a place you'd like to stay next week or next month. Match.com presented at our conference on doing this, which prospect is most likely to be a successful date.
Yeah, no, that's interesting, the way that you use triage. It's like essentially picking what's going to be sort of the best thing in any use case, essentially. So then I actually have two questions from this. One is, would it be possible in the future for smaller businesses to work with larger sets of data? Could you see in the future there being, services that are distributing like large amounts of data, so that, smaller businesses, just like larger businesses, can better utilize such data?
Yeah, absolutely. I mean, really, the value from machine learning depends on the size of the operation that you're trying to improve. And if there's at least thousands, hopefully tens of thousands of decisions that are going to be rendered within a reasonably short amount of time, then that's where there's a numbers game worth playing. And by the same token, if your operations are already that big, then you probably have an equivalently large amount of data, because the data that you're leveraging is typically not collected for these types of business applications. You don't have to go out of your way to collect the data that we're leveraging with machine learning, because it's accrued organically as a matter of doing business as usual. It's like a side effect. If it's already a large scale operation with lots of decisions, lots of marketing outreach, lots of transactions that are either approved or disapproved as potential fraud, you find out later where you made the right or the wrong choice. But either way, you're aggregating large numbers of transactions and historical occurrences, and that makes for what's called the training data, the data that you put together and feed into the machine learning algorithm.
Yeah. So then my next question is about how you use sort of like this triage across everything. In the future, or even like even now, can we see an increase in businesses trying to position themselves to serve the consumer and the community using this sort of triage, where they're trying to find actually they're more consumer oriented? Will we see like a rise in this? And sort of to take it further and to kind of give an example, will we ever get to a point where, let's say that I want to do my groceries, right? But I don't want to think about having to do my groceries. So will we see like, machine learning models coming up that can predict the groceries that you need for next week and sort of automating that process? Or in other words, businesses orienting themselves to serve the community?
I mean, that's a great question. And it's a sort of a spectrum between the large scale operations and where it can help an individual. Now, obviously in search results, like the stuff I just mentioned, that's where an individual consumer directly benefits. If you're trying to decide how to do your shopping, it's such a small scale operation, and it's such a personal thing. And it's the cost for you as a consumer to just manually change. Oh no, I don't need eggs every week. I need them every other week. And just, if there's something automated, great. But it involving prediction, maybe as suggestions. The place where it really pays off are large scale operations, because I keep using the phrase numbers game. What I mean is that it's not predicting like a magic crystal ball. It's predicting better than guessing. So it's going to say, hey, these customers are 3 times more likely to buy than average. Therefore, it's going to be a lot more profitable. If you do the arithmetic, how much does it cost to send direct mail to these people? How many of them respond and give us a profit? If you do the arithmetic and you've created with prediction, what's called a lift of 3, because these ones are 3 times more likely than average, the numbers work out great, right? So using a model to target marketing and all of these operations, target fraud detection, credit scoring, et cetera, comparison to not using a model at all, it's usually such a no-brainer. It's such a great improvement. But what we're talking about is, well, if it's marketing, let's say 1% in general respond, which would actually be very high for direct marketing. And if you had a lift of 3, that'd be 3%. You still don't have this really high confidence of any one individual. It's just a 3% rate rather than 2%. I'm sorry, rather than 1%. So what you've done is tip the odds in your favor in the numbers games that business are playing. And that pays off when it's a large enough scale operation, enough decisions, because we're not clairvoyant, and we can't expect computers to develop clairvoyance. It can't be a magic crystal ball, even with the most advanced type of machine learning method that fuel the incredible effects that we see playing with generative AI and ChatGPT and these kinds of things, even with amazing image processing that will drive a self-driving car to help decide how to steer, or where and when it detects a stop sign or a traffic light or a pedestrian. All of these really advanced, developed forms of machine learning that leverage such great amount of data and that make predictions based on lots of data, because it's not just a few dozen factors about a customer, but it's every pixel in a high resolution image or video. So the scale is amazing. The improvements and the advancement in the core methods, the core algorithms, are amazing, but it's never going to be that's never going to lead us towards solving this sense of unpredictability, in the sense that there's still an absolute ceiling. You can't predict like a magic crystal ball. It doesn't matter how much you know and how much data you've leveraged. I can't tell you out of this people exactly which are going to buy ice cream cones. I can say, well, I think on average 12 of them are going to buy an ice cream cone tomorrow. And that might be very different than some other population of people, and they may only have two that are going to buy an ice cream cone tomorrow. But I can't say which two, right? We don't create that level of of predictive capability. It's just unrealistic. So with those types of use cases where the value of prediction helps drive operations, with predictive analytics, if you want to call it that, it's making hay of the fact that there's a numbers game applied over a lot of decisions, and now we're tipping the balance in our favor. It's not hinging on some unrealistic, overzealous concept that the thing is going to become sort of supernatural in its predictive capabilities.
Yeah. So then how can we sort of reduce that error, right? It's not obviously magic, but it's not like we can't make our technology better, you know?
Mm-hmm.
So how do you see, this technology improving over the next 5 years, 10 years, and into the future? How can we reduce, this error rate so that instead of saying out of these 15 customers, 12 are going to get it, and we can say that 10 customers are going to get it because, some X reason that, these two can't get the code.
Yeah, I mean, that's a great question. I think that it'll always be incrementally improving it. But the more dramatic qualitative improvements are in two arenas. One is just getting the darn thing deployed. Because in these types of enterprise use cases, predictive analytics, predictive AI, whatever you want to call it, the main limiting factor is that it's just simply not being applied, or it's attempted to be applied and it fails because of organizational issues that actually very regularly prevent the deployment. So they may have a good model, but it doesn't actually get integrated, and the operations and their decisions never actually change. And then the other, in terms of the core technology, I mean, the place where we're going to see the most dramatic effects, although I have to say not as dramatic as the world thinks, is in generative AI. I mean, we're going to see continued improvements there, and it's absolutely amazing what's happening. That's sort of a whole nother conversation topic. I don't know if you're ready for us to move into that, but since I opened the can of worms, I'll just say I'm super excited, and the world is 10 times too excited.
Okay. Well, I guess actually that's a great moving in point. And I just have to ask you, this is actually something my dad was asking me to ask you.
Yeah.
He's super interested in AI as well. But the question is, do you think that, our generative AI tools right now could ever transform into something like artificial general intelligence, which, for those of you that don't know, it's basically the idea that we have almost like AI that can almost act and behave and function like a human. I don't necessarily know about conscience. That's a whole other thing to talk about in and of itself. But do you think that we could ever reach that point? Because I was reading this article. I don't remember the name of the CEO or the company, but he was saying that, in the next 3 to 8 years, we're gonna get AGI. And do you think that's currently possible with the way that things are looking?
No, man, I'm a super downer on this stuff. I'm
Yeah.
an AI skeptic, and I love AI, and I've been fascinated with it since I was 8, and I grew up with a distant relative who was a philosophy professor and had one of the first personal computers in the 70s, and he had the ELIZA program, and he was my pen pal about the philosophy. And I pursued this career into machine learning because my fascination at that stage of how could you replicate human intelligence, and yet here I am. I think that that's part of the hype. I think that the idea that we're gonna from my understanding, the best and most widely accepted definition of artificial general intelligence is that it can accomplish any cognitive task that a human can. Right. Mm-hmm. And I think they put the word cognitive to sort of say, okay, it's not necessarily a physical robot, but whatever, it can do it. It could run a company. It could be your ultimate administrative assistant. It can do anything that you would hope a human could on their best day and beyond. And then, of course, once you get there, then they can self-improve because they can conduct AI research. So now I have been, so a lot of us in the field, including myself, kind of get driven nuts by the overhype.
Yeah.
The overhype, however, with the advent of generative AI, the overhype has, I guess overhype is redundant. You can just say hype.
Yeah.
But anyway, you know what I mean? Like the hype is now suddenly 20 times worse than it ever was. And so it's sort of like, I always thought it was so bad, man. But now, so here's the deal. And I've written some. I have a Harvard Business Review article. AI hype is distracting companies in Harvard Business Review last spring. That's pretty easy to find. I've fully drafted another article that AGI is not coming anytime soon.
Yeah.
So here's what I think. I'm not saying the brain's not algorithmic, right? In a sense that I'm not saying that what a computer's capable of in principle couldn't do everything a brain's doing. I don't know. I mean, that's a philosophical thing, but let's assume that it can or could. Who cares? I mean, the hardware is not the issue. The issue is programming it. It's the software. It's the procedure. And what the brain, the human, is capable of, it's so much more than we realize. So there's this very awesome human-like effect when you're playing with a large language model like ChatGPT, and it's really impressive. And I spent 6 years in a natural language processing research group at Columbia during my PhD there, before I was on the faculty. And I never thought I'd see what we're seeing now in my lifetime. It clearly has accomplished so much in the ability to, in some level, grasp concepts, if you will, in an abstract way. Now that this is all very hand wavy because I'm talking in very abstract terms, but there's something there, but that does not mean it's headed towards human level capability. I mean, think of it this way. What it's capable of doing is only because of this awesome amount of data that reflects human cognition, that is all the written text. So I think that it's what's called critihype. And it's not too popular of a phrase, but I didn't coin it. It's out there. Critihype is where you're saying, hey, you better be scared of this stuff. It's so powerful. It could do really terrible damage, as a way to actually hype up its potential good. And it's sort of a sales tactic, which to one degree or another may be, maybe conscious and intentional on the part of executives. But the idea is, hey, look, if this thing could be so powerful that it gets a volition of its own and can manipulate humans and can take over the world and cause damage on a grand scale to the human race, it can probably also do a really good job of targeting your marketing too, don't you think? So it's a way of pumping it up. So I think that's part of the ulterior motives to this. And I think the key fallacy is what I call the great AI myth, which is that as technology is getting better, it's getting smarter, in the sense that we conceive of intelligence as a one-dimensional spectrum. And as things get better, and in some cases in ways that seems somehow human-like subjectively, or that is just more complex and more advanced. And as it's getting better, that means it's moving along this supposed one dimension of intelligence. And inevitably we continue down that, getting to the point of human level capability and beyond that. Conceiving of intelligence, though, as a one-dimensional concept is greatly misled. I mean, what humans can do is very multifaceted and very hard to define in concrete terms, especially with only one dimension. And the problem is that the word intelligence is intrinsically anthropomorphic. It's very particular. What humans are capable of are very particular as a result of how we evolved in this very particular environment on this planet, in order to create capabilities that served our survival. It's a very, very particular thing. The word intelligence is subjective, and you can't, any attempts to define it always fall on their face unless they just give in and say, okay, we're talking about humans. It's not some platonic ideal of what intelligence is. It's just something particular to what humans can do. And that's ultimately what people do when, instead of defining AI in terms of, oh, it's really good at these kinds of tasks, or it operates in this way, and none of those definitions turn out to suffice, because they're either ill-defined, so you can't pursue them. They're too subjective, or they are, have already been accomplished, and it doesn't suffice for AI in the full sense of the intended spirit of the word by the AI believers. So what you end up resorting to is AGI. You're like, well, ultimately where we're headed is AGI. So then, okay, now we do have sort of a concrete definition. It's very hard to test for, but you could kind of conceive of, hey, let's say we set up a battery of 100,000 or 1,000,000 tests that are representative of all the many different things humans can do. And then we could test the thing. At least it would be tested. It might take, just to conduct the test, might take 30 years because it would include running a Fortune 500 company.
Yeah.
But, at least in principle, there's something much more well-defined than your typical definition of AI, which is circular, which is intelligence demonstrated by machine. It doesn't mean anything because intelligence could mean anything.
Yeah, and I like the way that you use anthropomorphic, because it sort of assigns a different value to being a human. Like, if you think about it, as you said yourself, we've kind of evolved in our environment to get to where we are. And because of that, we've developed instincts, right? That I just don't think we could probably find in an AI, or sort of, I guess, develop in an AI, because from a, like, we're inherently different. Humans and AI, there's a big clear divide, and the same things that, like, the self-preserving instinct that humans sort of have, I don't think you could give that to an AI, because there's no way to define that programmatically. And I just think that that's something like AI in and of itself. Um, I just don't think we could ever experience a sort of like Terminator example happening in the world. That just could simply never happen, especially with our current capabilities, and that sort of divide between what it means to be a human and what technology currently is. And I think this is actually a good.
So let me
Yes,
ask
go
you a
ahead.
question then. You use the word programmatically, and I think that sort of alludes really to the fallacy of the AI of the 70s and 80s, right? I mean, we've gone through this. We're in our third wave of AI hype, and each one ends with what they call an AI winter, a
Yeah,
disillusionment.
I've
And
yeah.
and so the programmatically thing is sort of, can you introspect, right? Can you think, can you look at your own internal phenomenology and
Yeah,
say, oh, this is how I think about things? And you can, to a large degree, but not nearly enough. Most stuff you're not conscious of, unfortunately, or fortunately, depending on how you look at it. So we can't just think about how we think and then program it. But that's all kind of been eschewed with the first or second AI winner. I kind of I lost count. But for sure, right now, the hype's not around that supposition that you're supposed to be able to understand how you think, but rather that it's being programmed from scratch. It's programming. That's what machine learning is, in a certain way. It's programming itself. So how do you, if you concede that, nah, we're too complex to understand ourselves, that's not going to work. What's your opinion about the current hype wave, which is that, hey, this thing's learning from such a large amount of English text or natural language text across languages. It's definitely capturing generalities and capabilities, right? Why not just keep going? Like, what do you agree with me, or do you have another view, or are you agnostic? Like, could it continue to sort of, is there a ceiling, or is it going to just keep getting better in some sense?
I think that AI in and of itself, like, I do think that there's some sort of ceiling, some sort of limitation to what we could end up doing. But I feel like that limitation's always being pushed by, our discoveries, our research, our advances, all that kind of stuff. So, I feel like as time is going to go on, AI technologies are going to get more accurate. They're going to definitely get more, they're going to be easier for everybody to access. So accuracy, accessibility. And I just like to see AI more as sort of a driving force for positive change in the world,
Mhm.
opening more opportunity than rather destroying, like sort of like or rather getting to a conscious AGI type thing. I mean, obviously, in essence, AI is what its data is. Whatever we put in, we're basically going to get out. And the patterns and the behaviors that we see, in AI today are patterns and behaviors that, you know, that we as humans have done, on the internet, all that written text that we're feeding in. Um, and so that's really what we're going to find. And as human civilization evolves, culture evolves, things change. AI is also going to be changing with that, um, culturally and research-wise. It's going to get better to a point, but I just don't think we could ever mirror conscience, um, like that, because I feel it's just not. There's a divide. That actually, there's an idea that I have. Um, I think it might have been done before. There was a YouTube video that where this guy sort of created this reinforcement learning environment. And you can sort of model evolution to some degree. Um, we wouldn't like, would we consider something that's evolved under that um, program basically to have this sort of um, equality to an animal in the real world? Like, where's that sort of boundary, that line? um and even then, like, to a bigger point, I've been thinking, what if we could, model the way that the universe works, using artificial intelligence, right? Because there's just so many different things. um could we make it so that, we figure out the unknowns about this world, and it just sort of goes to show, you know possibilities with AI are limitless. There's a lot to do. The best thing to do in today's world is to understand what's happening behind the scenes. Um, and I feel like if people just get a better sense of what's going on, they can better position themselves in today's world to utilize AI to change their lives in a positive way. Um,
I
so
think
that's
you really
yeah.
brought up a good crux of the philosophical dilemma. Um, I mean, what you're alluding to used to be called artificial life. Maybe it still is. And I was really into it in the 90s, as a lot of people. My main focus on machine learning back then was genetic algorithms, genetic programming, which has some advantages potentially over neural networks. But either way, it's about trying to solve the problem effectively, um, by learning from examples. But there's sort of some overlap between that particular sort of the evolutionary type, also called evolutionary computation, those approaches, and what's artificial life. And artificial life is you've got this artificial universe with its own rules and physics or whatever, and then the organisms are competing for survival. Now, that's a very different thing than just trying to improve a word prediction method, right? Because if the simulated universe is sufficiently complex, then maybe you'll get things that are really complex organisms, and then you could start to argue, wait a minute, does this thing qualify as life? Could it be conscious? How do you define consciousness? It's that's pure philosophy, and it's very interesting question. That's kind of fallen out of fashion, that field, but I'm glad you brought it up, because it occurs to me now that compared to the 90s, if you conducted those experiments with today's computational power, you probably would get a whole new level of qualitative results, and would, in a way that really tantalizes those philosophical questions. Now, having said that, I don't think that even if you evolved an organism anywhere near as complex as real life organisms on this planet, it's not like the organism in your artificial simulation would actually be useful, right? It's not like it would, or definitely not approach human level capabilities, because what we're good at as humans are particular to this environment, and what it would be good at is particular to its artificial environment. which at best is a very rough emulation of the real world, right? So it might get really, really good at solving problems in some particular way for its artificial reality, but that's not necessary. There's no reason to think that that would map to usefulness in our. So as a way to actually solve the quote AGI problem, it doesn't seem, I don't see how or why that would align. But in terms of approaching philosophical questions, it could be really fascinating. I'm sure it's still going on out there, but I don't hear about it. Much less a point of focus than it was a few decades ago. So I bet you we're going to see that come back.
Yeah, I would be interested to see what would happen if those types of experiments came back. I've loved to work with reinforcement learning a lot. It's just really fun. It's like seeing somebody sort of ride a bike over and over again, seeing how they improve, and I just find it fascinating because then there's so many things you can do. Like, I know that the Tesla cars today, they've been trained, I think, to some extent in a sort of reinforcement learning environment. Um, there's this YouTuber who releases these Trackmania videos where he tries to there's a video game called Trackmania where you have to get a car to an endpoint and you have to go through obstacles and all that kind of stuff. Um, and it's just interesting to kind of see the cumulative build up to that. Oops, sorry, I touched the mic. The cumulative build up to that one point where that AI just finally goes through, and it's really satisfying. So I think for this last sort of segment of the podcast, I want to kind of ground it back to policy today in the real world. So I was reading this article about AI licenses. And I think part of it was propagated by a lot of fears that people have of, AI getting out of control. But there's a lot of big companies that are sort of capitalizing on that fear where I think what's happening is that people these companies are suggesting these AI licenses before you deploy your model to market. You kind of have to verify your model that it's safe, it's not dangerous, however you would define that. But do you think that we should have these sort of things? And to the next level, what do you think that the government should or shouldn't do in terms of AI use in various industries to promote economic growth?
Yeah, no, that's a great question. No, I don't think the regulation should be on making sure the model's not too powerful. I think that's part of the AGI hype. I think it's part of the crita hype, as I mentioned, it helps hype it up by kind of criticizing or say, be careful. I think that the regulation issues and the responsible use of machine learning issues comes in how it's used in its deployment. Right. And so it does so what I just said is sort of something you're hearing from a lot of there are sort of two camps. There's the people who are all AGI warning crazy, and then there's people say, hey, what about the ethics? I've actually been focused on the ethics of biased or discriminatory decision making in machine learning for a long time. It's the focus of the second chapter of my book. The first edition was in 2013. So I handled it up front in the book, and I've written about 12 op-eds published in the San Francisco Chronicle and the Scientific American blog. If anyone's interested, it's at civilrightsdata.com are my list of op-eds there that are linked. But basically, it's not whether the model's somehow too powerful or going to take control or something like that. The control is only the degree to which we apply the model and use it to drive or inform decisions. And there is very much the potential for those decisions to be biased in the sense of having different false positive rates for different groups of people, or even for models to take directly as input a protected class like race, ethnicity, national origin. And there are some very esteemed experts in machine learning ethics in particular who espouse allowing models to take those protected classes so that the model would literally be making a decision based in part on your race, for example. So unfortunately the jury's still out as far as those kinds of responsibility guardrails, and whether there's accessibility to the model to inspect it, to get it to provide an explanation, at least in the public sector. And again, the jury is still out. There are models that are used that are to directly inform sentencing and parole decisions. So how long someone's in prison, that operate on the history of that particular convict in a way that's a black box. And I don't just mean a black box because it's a complex model. I mean because it's proprietary. You're not allowed to access it. And I understand that even if you were allowed to access it, it might be hard. But there are plenty of methods for interpreting it. The question's a legal one. We should be allowed, especially in the public sector. It's like not being allowed to cross-examine an expert witness who's spoken against the defendant. It's absolutely ludicrous. It's a no-brainer. So there are some really significant issues around the responsible use of whether it's machine learning or any automatic system that's going to inform or sway many decisions about how long people are in prison, who gets housing, who gets credit. So this is a civil rights issue. This is the core of responsible machine learning. And I would say that the state of the world is that corporations have very nice sounding platitudes in their public relations statements about how they're going to be responsible and fair, but those words are wholly subjective unless you define them more specifically. So the standards we need to live up to are going to be up to individuals. The corporations have their hands tied. They can't put down concrete. They can't come out publicly with concrete safeguards and standards that they espouse, because if they do, all of a sudden they're taking a position on one side of our major political divide or the other. But if you don't, then you're just sort of allowing these things to be biased.
So then how do you see, like, how can we mitigate this sort of bias? I know that part of it has to do with training. When we enter data, we can eliminate bias. But, when it comes to like human characteristics, race, ethnicity, religion, all those kinds of things, how can we sort of eliminate the need of those things when making decisions, or rather, just overall, how can we
eliminate their involvement in the decision? Is that what you mean?
Yeah.
Well, you can measure their involvement. So even if typically the models do not directly include protected classes, so and it's often illegal, but not always. But typically the practice is, and even though there, as I mentioned, there are proponents of it, it's typically not done. But even when it's not done, you get this effect that, there's a famous ProPublica article called Machine Bias, and it looks at one of the crime prediction models. What are the chances you'll be convicted again after being released as a convict? And what they showed was the false positive rate for black male convicts is twice that of white male convicts. False positive rate. So how often is somebody who is undeservingly given a high risk score, something that would propel a judge or a parole board to keep you in prison longer? How often is it unfair in the sense that you're not going to commit a crime again, you're not going to be reconvicted after release, but it's saying high score? Because the fact is, models like this, click, buy, lie, die, these are the kinds of outcomes or behavior, especially of humans, that are not going to be predicted like a magic crystal ball. The model will make mistakes. So if you want to look at a question of fairness, how often is it making that mistake in the bad direction for the convict more often for one race than the other? Well, this is a very clear-cut example. Even though it's not basing the decision directly on race, there's other factors that essentially act as proxies, and this is the net result. people who think that that's sort of okay for a model that's in public use to have that attribute say, well, look, the Black population is committing crimes on a higher rate on average. And therefore, this is just sort of a natural side effect, unfortunately. We weren't intending it, but that's just the way it works if we're going to make as accurate a model as possible. My argument would be no. What we're seeing right now is a reflection of a problematic society and the history that we're all so familiar with that led us into this place. So in fact, this isn't an indictment against the model or the analytics or the math. It's an indictment against society and an opportunity, because now we're using this thing to inform decisions. All we have to do is a little more arithmetic on top of it to adjust for that unfair balance of false positive rates.
Yeah, so we can.
But to do that, you have to do something equivalent to affirmative action. So you have to reintroduce race. And for the reasons I just described, I'm very much a proponent for that type of affirmative action, so that you're basically holding a different standard by race, so that you're evening out the false positive rates.
Okay, so you're saying that we should reintroduce race as a factor of these models in sort of an affirmative action way, but also reduce.
Well, you don't reintroduce protected class into the model itself, but this is, again, as I sort of said, the issue is how do you use the model? Yeah. So now, I mean, there are other technical ways where it would involve it in the model itself, but just for simplicity at the moment, we've got a model that has this characteristic, this problematic characteristic to its behavior. Now let's take its output and in the processing of the output, reintroduce race, so that we can balance out and have an equal false positive rate.
Okay, so I kind of see where you're going with that. What was really interesting that you said was a reflection of a problematic society. And
yeah, I mean, that's the whole point. That's the context, right? We're not living in a vacuum. It's not just cold numbers. This all reflects a situation that we're in now, which is very much a reflection of history.
Yeah, and we were just talking about this earlier. Data that goes in comes out. And so I guess as humans, we should sort of, like strive to make better decisions, be better ourselves, to, I guess, really what's going to happen, improve the outcomes of other people. So I guess what we do directly affects what happens to others.
Yeah.
Okay, so I have one last question. And I think this is for the 2024 election. How do you see predictive analytics being used in the 2024 election?
In Obama's 2016 re-election, that was the first time it at least publicly known that they used predictive analytics to target the main campaign activities.
Wait, 2016 or 2012?
12. I'm sorry.
Oh, okay.
Thank you for correcting me on that. I'm way ahead of myself. 2008, he was elected. 2012 was Obama's re-election campaign, and that was when they used predictive analytics, and it became publicly known to target all the main campaign activities. So this army of volunteers, which is sort of like the sales force for a company, is going to go make a bunch of phone calls and knock on doors. And they were targeted. They were never sent out and said, go knock on every door in this neighborhood. No, they were given a specific list of addresses, and they were to avoid the ones not on the list, because they were targeting to people who were potentially persuadable, where they would have a positive effect on the chances of getting a vote for their candidate, Obama. Whereas it turned out that there were some houses where there would have been the reverse effect, just statistically, and they showed that with the model. So they avoided those houses because you don't want to increase the chance of somebody voting for the other opponent. So we, based on sort of the hiring and some of the staff overlap, it became clear that Hillary for America in 2016 almost definitely also used it, but obviously if it helped, it didn't help enough. I don't really know what happened in 2020, but this, as far as the use of this technology, but I think that it's a factor. It's, a political campaign is a marketing campaign like any other. And in fact, it's one of the highest stakes ones in the world. And it happens much less frequently than your typical marketing campaign. So there's every reason to believe that the most powerful use of these methods would be applied.
Yeah, that sounds really interesting. Yeah, this 2024 election is definitely going to be another interesting one for people in America. Yeah, it's just I think the Republican debate happened just like last week, I think. And it's just sort of interesting to see where it's been going.
Yep.
Yeah, there's a lot to talk about over there. But I just wanted to thank you so much for coming on to Machine Learning and the Sciences. This was, by far one of my favorite episodes. It was really, really interesting
Awesome.
talking to you about, AGI, predictive analytics as a whole, and, government. I'm so glad that you came on today. Thank you everybody for watching today's episode. We'll keep you updated on whenever the next episodes are going to be coming out. Once again, thank you so much, Eric. This has been great.
Awesome. Yeah. Thank you, Yash. Thanks so much for having me.
Thank you so much for tuning in to this episode. We hope you'll join us again soon for another episode of Machine Learning and the Sciences. Before we sign off, we'd like to give a special thank you to Zach Benitez and the rest of the team at KCAT TV 15. I'm Yash Sharma, and keep exploring the exciting world of machine learning.